In this section, we're looking at a binomial probability distribution, which is defined by these four characteristics, where we have n repeated identical independent trials. So n is the number of trials, and they each need to be identical, like doing the same thing over and over again, and they have to be independent of each other from a probability perspective. Each trial has two possible outcomes. We usually call these success and failure, and the probability of success takes on the value p, and the probability of failure is q. And now, since in each particular trial you're either going to have success or failure, that means that p and q must add up to 1. Our binomial random variable x counts the number of successful trials. So x counts the number of successes. And of course, that can take on integer values between 0 and n, since you have n trials. In example 92, we're going to look at sort of a situation, a scenario where we could envision what a binomial probability experiment might look like. So we have a situation where you're going to show up to a class, and perhaps your teacher surprises you with a pop quiz. And you've got 4 multiple choice questions, each of which has 3 possible answers. So they're basically sort of identical situations. In each of these 4 questions, these 4 trials, you're going to pick 1 out of 3 answers. Now, supposing that you haven't prepared at all, and you decide you're just going to guess randomly. You're just going to guess for each one. So that means that we really do have 4 identical trials. And they're independent because, of course, not knowing the answer on one of the questions, guessing, isn't probably going to change the probability that you might happen to guess the right answer on the next problem, on the next question. So our n here is equal to 4. Since each of the questions has 3 possible answers, that means the probability that you're correct, that you guess the correct one on each trial is the same. And so that's our value of p. And our p is the probability of success. And so we'll count sort of maybe perhaps naturally, we'll let success be that we guess correctly. And so that means the probability that we guess correctly on any particular question is 1 out of 3. And so the probability that we guess incorrectly is 2 out of 3, right? P and Q do add up to 1. And x counts the number of successes. X counts the number of questions that we got correct. And can take on values between 0 and 4, right? I could possibly get them all wrong. There's a small chance I might get them all right, and of course it could take on any value in between. And so these are 4 repeated identical independent trials, and we can conclude that this is a binomial probability experiment. Oops. Now we're going to sort of pose the following questions, and then we're going to do a little bit of sort of digging around to try to perhaps figure out a way we can approach situations like this, where we have a binomial probability experiment going on. So, we might be interested in figuring out what's the probability we get more than half right, or perhaps maybe there's a chance that we might get them all right. If the entire class was unprepared and so everybody guesses on the quiz, what should the average number of correct answers be? In a probability experiment, what does it mean to talk about the average? And if I did guess, how many could I expect to get right? What could I reasonably expect as my number of correct answers to be? And so we're going to spend a little bit of time exploring this example a little bit further in the coming questions.